go through a few, trust me. Yeah. Alice. Ben. Abby, Dylan. Eliana. Megan. Megan. How is Jensen doing? How is Jensen?
She's good. She's going to class this weekend.
Okay. Zachary.
One.
Zach.
Which one?
Aaron Burke. Abby Gertner. Martha.
So much.
Caden. 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 Max. Aubrey. Haley. Nadia Holtz. Lucia. Nicole is over there. Emmett's right here. David. David. Bella. Sherry. Adita. Logan. Nico.
So obviously it has to have the same.
Samara. Samara. Esther. Brooke. Zach Shapiro. Sebastian. Who goes by something else? No. Jacob. Great. David. Caden. All right. So this is an example of something that topics I'm allowed to ask. Do you remember geometry? Do you remember algebra 1? Can you write equations of lines? In calculus, we're going to ask you for equations of lines all the time. So, first thing, to write an equation of a line, what's one of the things we need? Slope. How do I find slope? Yeah.
Y2 minus y1 over x2 minus x.
So, slope is change in y over change in x. Okay. So slope of AB, label your work somehow, say the word slope of AB or AB sub m, I don't know. Give an indication of what that floating arithmetic on your paper is. So y minus y over x minus x. But you know what? How do you know which one is x1 and which one is y1? So let's say that Hannah wants to do it this way. She did 4 minus 7 and negative 6 minus 3. Is she also correct?
Yes.
Yes. Whichever way, if you choose that y value first, choose its counterpart first in the denominator to make sure that you get the slopes right. Okay, so I have the slope of AB. Is that the slope that I want? What do I need?
Perpendicular.
How do I get perpendicular? Do what?
Flip the denominator and
Flip.
and it's negative.
Okay. Negative reciprocal. Whatever it was, turn it upside down and change the sign. Okay, so there's my perpendicular slope. All right. Zach, I need the equation of a line through point C. What would you do?
I'll probably take the perpendicular slope and then like find a point where, like, so it'll be -3/1, so then if we're gonna, if C is 3, then
Okay.
find where.
Right, now,
So
you're
x
looking to find the
axis.
B value
Yeah.
for the y equals, okay, so let me show you, welcome to calculus. This is actually a benefit. Right here in the slope equation that I was told earlier, I'm gonna cross multiply. This is an equation of a line, and this is where I want you to stop. So it's y minus the y value of my coordinate. The y value of my coordinate is -5. Equals the slope, that perpendicular slope that we found, x minus the x value. Stop there. It's not wrong if you continue through and you solve for y and you get it is the y equals mx plus b form. However, if you make any mistake, drop a negative, add a negative, lose parentheses, make a mistake moving things over, you took a full credit thing and lost a point. Stop there. Circle it and move on. Welcome to calculus. We prefer it this way. So that's the equation of a line. So we have been like beating it into your head that you need to get the y equals mx plus b. You might still find that useful for some later application, but that's what we're looking for. Okay? What about the equation of AC? What's the slope of AC? Emmett?
0.
How do you get 0?
Oh no, I mean undefined.
Okay, how do you get undefined?
Cause it's 7 minus -5, which is 12, over 3 minus 3, which means it's undefined because 3 minus 3 is 0.
Can't divide by 0, so, but that's a vertical line, I should be able to give an equation of it. So what is the equation of that line?
X equals 3.
X equals 3. Right? Do you remember these? So, no. Some people are like, don't remember that. Okay. So, perpendicular lines make negative reciprocal slopes. That's from geometry. Equations of lines. A vertical, straight up and down. That's a no slope. That's the kind of slope that you can't ski. It's called falling. Versus when it's flat like this. The flat of the z goes with the flat horizontal line. That's 0 slope. The flat of the n for vertical. That's no slope. Cool. Okay. Pre-COVID, we actually gave people hard packets of paper, like it was a 20-something page packet of problems. That is now what the Delta Math is based off of. But here is the original packet. This is posted online if you wanted to look at it along with the solutions. But these are the kinds of questions with more precise wrinkles to it. For example, number 3. Ryan, how do we factor the denominator in number 3?
X plus 6, x minus 6.
Yes. Okay, so that denominator, x plus 6, x minus 6. Does this numerator cancel with one of these factors in the denominator? Yes or no? I hear half and half. Haley, why not?
Because the x is the negative.
Because okay, so pick a number for x like, I'll pick 8. Is 8 minus 6 equal to 6 minus 8?
No.
No. They are 2 units away from each other, but they're not, this is positive 2, that's negative 2. In order to factor, or to make it work out, I need to factor out that negative. I'm gonna make the negative x positive. Haley said that's a problem. Well, I can't just take the negative off the x. I need to take it off the positive 6 as well, which makes positive 6 actually negative 6. Now these match perfectly, and it becomes negative 1 over x plus 6. So the delta math, I created the delta math with this packet in front of me. I can't guarantee that it brings this kind of question up to you. So I'm pointing it out now. This is what's the difference between AB calculus and BC calculus, is being more careful with the details. Like, you're all good at this, and visually, they'll give you things that, it's the way they write it. You know the math, but the way they write it is like, you will choose the wrong answer. They do this thing. They're magic. They really are. You guys are kind of allergic to fractions too. Fractions and fractions. Like I said, what would you start this question? Like, I need to flatten this. There's a couple of good choices. No? Emmett, what would you suggest?
Multiply the top and the bottom by xy.
Okay, so that is what I do. And in this case, it is unfortunately not the better choice, but it works. So he said multiply by xy over xy, because that makes that top denominator go away, which is a good thing. Down here, the y's go away, so it becomes x times x plus y. And then Ryan did some factoring for us a minute ago. How does the top factor? Very much the same. Ashley. Yep, difference of squares. X minus y, x plus y. And we end up with this. Does anyone have a different way of doing this problem? Yeah.
Multiply just the bottom by x over x.
Okay, we could common denominator it, which is what delta math does, and then it'll take us to a lot of this. There's another way. Yeah?
Wait, I'm not sure, but could you like flip the bottom fraction and multiply it with like the numerator of the fraction?
Okay, so she says, dividing by that fraction, division becomes multiply of the flip, multiply by the reciprocal. And then factoring like Ashley just did. And then the x plus y is canceled, this y cancels, and I get the same answer that I had here. So there's several valid ways to do the problem, which I'm not, it's rare. I will force you on chapter 2 to do certain problems certain ways, because you need to show you know the foundations. But it's rare that I'm gonna be like, you must do it this way. There were 3 different things. You could have done it Emmett's way and multiply the top and bottom by x o y. You could have done it Abby's way and do common denominator and work it out that way, or you can multiply by the reciprocal. They're all perfectly valid. In this case, multiplying by the reciprocal was the more efficient way. Okay. Trig identities, everybody's favorite in pre-cal, right? Uh-huh. The silence comes over the room. Sebastian, do you remember what sine squared plus cosine squared equals? 1. If you can only remember one of them, that is the really most important thing. I can generate the other 2. If I divide everybody by cosine squared, what is sine over cosine? What trig function? Tangent. Okay. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. Okay. Which one is it? Cosecant squared or secant squared?
Secant squared.
Okay, good. Okay, so I generated that one. dividing everybody by sine squared. Sine squared divided by sine squared is 1. Cosine squared over sine squared is cotangent squared, so 1 over sine squared is cosecant squared. Okay, yeah. Anybody remember this one?
Isn't it like 2 cosine x sine x?
Yes, and I can't write it that way. In my head, it's always 2 sine x cosine x. Yours is exactly right as well, but I need the sign to be fitting first because it hurts me to do it otherwise. Oops, I turned the page. Yay. Okay, so, yeah,
For the next one?
hold that thought. So, if you can only remember one, knowing that one, and I'm not even counting knowing the reciprocal functions. You need to know 1 over sine is cosecant. Like, you need to know those. If you can only remember one trig identity from last year, this one's really important. If you can fit 2 in your memory, this one's pretty good. You know the next one?
Yeah, I think it's cosine of x. No, wait, hold on. Cosine of x, wait,
There's 3 choices.
or no, I'm trying to remember. No, I was thinking of
Okay.
cosine of a plus b.
Yeah,
Wait,
you don't
is-
need to know that. I will use that. Esther?
It's the same.
2 cosine squared x minus 1.
Yep. Did you have another one?
Cosine squared x minus sine squared.
Do you have another one? That one?
2 sine squared x plus 1.
Close.
Oh, 1.
Okay, so in pre-cal, I show this, I do the proof of this with distance formula and law of cosines, and you end up with cosine squared minus sine squared. But using this equation, I can solve for sine squared or solve for cosine squared, swap things out, and I generate the other two. You don't need to know those. Keep turning the page. Like, okay. I use these, and I will show it to you 5 or 6 times through the year. This equation, because when we get to integration, you cannot integrate sine squared. However, I can make sine squared equal cosine 2x with stuff hanging off of it. It's just numbers though, not variables. I can integrate cosine 2x. I can't integrate sine squared. I can't integrate cosine squared. So I will use this. And I will show you, and on the AP exam, they'll let you use a calculator in this kind of case. However, every year it happens at least 2 or 3 people, my calculator died during the calculator portion of the test. But that's okay, because you never let us use a calculator anyway, and I did just fine. I'm still on the wall. Cool. So they were quite comfortable with their trig. Okay. Is this true? No, can you see it?
Oh, yeah, I'm struggling a bit there.
Well, just can you at
I
least
can see it.
visualize?
I can visualize what's happening. Thank you.
Okay.
No.
Okay, here, no, it's not true. So it's easier to just solve for y. Like, just find out what y is and see if it equals what they told us. How do I get y out of natural log? E it, exponentiate. So e to this side, and I need to do e to the parentheses entire other side. E to the ln of y, what does that become?
Y.
Just y. These guys cancel out, this is just y. Right, before we do that other piece, X squared times x to the fifth, what is it?
X to the 7.
Good job, Abby. It's x to the 2 plus 5, which is x to the 7. Okay, so you guys always skip over this. You do the addition in your head and you go right there. I'm showing you the addition here, like this, this addition. How do I pull the addition apart? Yeah.
You multiply e to the fourth times e to the ln of 6.
So just like you do with these all the time, so much that you skip this step, you immediately roll over it. Pulling apart this addition, it becomes multiplied here. And e to the ln of 6 is just 6. So Max, are they the same? So then you're right, it's not true. Okay? You all right? You guys have, at least it's not like painfully hot in here today, it's just painful math instead. Yay. Okay, all right. Exponents. How do I rewrite the little check mark thing as a 2 over 5 or 5 over 2? Which one is it?
2 over 5.
2 over 5, okay. And this wants it to be simplified and not leave negative exponents. How do I do that? Marta, any idea?
You subtract the exponents.
Okay, so how do I subtract 2/5 from 2?
Like, would you change 2 to 10 over 5?
So common denominator, x squared can be written as 10 over 5, and then she says subtract them, so it's going to be 1 over.
X to the power of 8 over 5.
Perfect. Yes. Um, $18, which those of you who can't really see it. Does E and ln cross out and do I get 4x?
No.
No, immediately no. Why not?
Because the 4 has to be the exponent on the x.
Okay, because the 4 is in the way. E and ln cross out when they are right next to each other. They're not right next to each other. So she says you gotta get rid of the 4. And the rule of logs, that 4 can come in as an exponent. Now does it cancel out? Yes. Questions? Question? No? Trying to make sure we get to the same point as the other class. Okay, here we get to the visuals. These, you can do these problems, and visually, the way it works, you guys are going to get it wrong. This one is not that, what I do wrong.
You didn't distribute the thirds per 5.
Okay, the exponent needs to distribute to everybody. I got 2 kids. If I give this one candy, if I don't give the other one candy, there's going to be fits and rolling on the floor and arguing. The exponent goes to the 5 as well. So it's 5 cubed. And raising a power to a power, 2/3 times 3 is just 2. Okay? Rewriting this one without the negative exponent. You guys can do this usually fine, but visually this one hurts you. What is that written with no negative exponent? Yeah.
Negative 3 over.
Shh.
Negative 3 over x cubed.
Okay. At least one person, you guys are like, oh, they're friends. I want them to hang out and stay with their friends. And you take the coefficient and you put it down there too. Coefficient is not got a negative exponent. Coefficient stays up front. just, I don't know what it is, but that one, you guys, are like, oh, it's negative, you can go there too. No, 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 resist. Don't make up math. Without a calculator, what's the answer to 23? 9. How'd you do it fast?
Just did the cube root of 27, and then, after that you get 3.
Okay,
and 3
make the numbers smaller before you make it bigger. Perfect. So, I've had kids do 27 squared and they're writing it out all over, doing arithmetic like crazy on the test, and then trying to figure out how to do the square root of it, and again. But cube root of 27 is 3. 3 squared is 9. So you know that you can do this with the fraction of an exponent? Yes? And if you didn't know, comfortable with that idea now? In all of this is just factoring. Hopefully you guys are good with factoring. 2 ways to solve 28. There's the algebra 1 way and the algebra 2 way. Suggestions?
Square root 8 plus or minus 25. Oh, it's plus or minus 5.
Adding 3, so all right. What's the difference between those two things? Great, Max?
For the x equals square root of 25, you're only going to take the positive, whereas it's going to be plus or minus with x squared.
Okay. Eloquent, yes. The first one, I put the sign on the square root. It was there. I only want, it's not written, but I only want the positive one. So it's x equals 5, boom. This one, he put the square root in. He needs to go, I don't know, it might have been the positive, it might have been the negative, maybe both work. When you put the square root in, you need to remember plus or minus. And you might throw out one or maybe even both of those answers, but you need to know to check. Cool? So this is the algebra 2 way. Square root of this, x minus 3. Why didn't he do plus or minus? Well, he did it here. You don't need to do it with both ones. You don't need 4 different cases because 2 of them are going to overlap. Algebra 1 way of solving this, expand this. And factor. And we still get the same 2 answers. It just takes a little longer. But the other one, if you don't remember the plus or minus or you do some adding wrong, the whole problem's hosed. So. What would your first step be in 30, Zoe?
Dividing 16 by 2.
Dividing 16 by 2, okay. Now what?
Oh, I've moved the 2x over to the other side.
Well, it's now an x, but
Yeah.
yes.
And then x, like factor it.
Okay. A lot of you are tempted to do this divide by 2x, especially when it's written this way, and you get this, but you threw away the x equals 0 answer. You threw away half the solutions. Don't do that. It is worse on 32. It's much more, like, this one visually, there's all kinds of things that they're goading you into doing wrong. First thing, sine 2x. you need to know that expansion thing. Logan, do you remember sine 2x?
2 sin x cos.
Okay. And then equals sine x, we need to do what Zoe just did and subtract it to the other side rather than divide by sine. If you divide by sine, you're losing more than one answer. Will, what do I do with it from here?
Sorry, I was going back to the other one.
Okay.
Would you factor out the sign?
Yes. Pick a name I don't remember. Brooke, what would I do here? So now it's where does each of these equal 0? Do you remember your unit circle?
Yes, you would find x, but it's in radians, not degrees, so sine x equals 0 would be 0, comma pi. And do you want me to do the other one?
Sure, do you remember?
And then I think it would be, no, it would be part 3. And then it would be negative pi over 3, but you're not gonna want that. You're gonna want 5 pi over 3.
Wow, that's really impressive. Like, did that pretty quick without any, like, she did some air stuff but didn't write anything down. Some of you, I don't know, I believe all of the honors pre-cal teachers teach unit circle like I do, which is to not actually use a circle. We show you 2 triangles and a bullseye. And with that, you should know everything. I've had students try to find the time to write down the entire unit circle on a little corner of the paper and then pick the one thing they need to know. Please don't waste your time doing that. If we have time, I will show you how these are generated. But if you know these two across from pi over 3 is root 3, 1, 2, 1, 1, almost 2, you can know everything. As long as you know how to spell SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So we wanted, where is cosine? 1 over 2. Where is this adjacent to? It is adjacent to pi over 3. Where else is cosine positive? 1 and 4. Okay? And I said the bullseye, if this is a radius of 1, and you can say these coordinates, alphabetical order, cosine, sine. Cosine of 0 is 1, cosine of pi is -1, sine of pi is 0, sine of negative pi over 2 is -1, cosine of negative pi over 2 is 0, tangent of pi over 2 is y over x, 1 over 0, it's undefined. So you can get all the things from knowing 2 triangles and a plus sign. And me and most of the other calculus teachers, we do still draw little triangles in the corner because we don't feel like thinking. We'll draw the triangle and be like, x pi over 6. Oh, wait, in quadrant 2, fine, 5 pi over 6. You guys okay with those? Right. This is about as far as I went in the other class. So, look through things. I will try to point out stuff that I think are weaknesses. You guys can go put the cards back and get your phones.